Hello, I am Dr. Stephen Lynch, the Chief Geoscientist for the Visual Wavefield Project and the developer of the Seismic Terrain Explorer software that you're looking at now. If you've been following my work, you'll notice that I've been unusually quiet lately. That's because I've had my head down finishing my latest release of the Explorer. I find it hard to talk to both humans and computers in the same week. So when I'm developing, I usually don't talk to anyone until I'm finished, which I am. So it's time to reintegrate myself into the geoscience community, and what better way to do that than with a quick presentation of one of the new aspects of the Explorer, specifically dynamic displays and how you can use them to provide context to attributes. To begin, I'll use the F3 demo data from OpenDetect, and I'll use two versions of it that they created and that come along with the demo project. The first is their dip-steered median filter seismic, which you can see here is a major improvement over the raw data. And the second is their acoustic impedance volume. I'm going to put the two together in entirely new ways and show you how you can get far more out of the AI attribute than you ever thought possible. Let's start by going back 40 years in technology and looking at this data again the same way you would look at it today, as variable density displays. Here is the seismic, and here is the AI attribute. There are two problems here. The first is that whereas this AI display is very pretty, it isn't very informative. There are lots of reasons for that, but primarily it's because we may be familiar with seismic and we may understand what it's telling us, but this is different. It takes us out of our familiar seismic context, and it makes it very difficult for us to physically relate what we're seeing here back to the seismic it was created from. Without the seismic to ground us, this is really just so much abstract color. I should point out that this is not just a problem with AI displays, it's a problem for all attributes. They all lack seismic context. The second problem is this display itself, the venerable old variable density display. We have used it for almost 40 years as our go-to display for seismic amplitudes. But it doesn't show amplitude. It only shows color, color being a proxy for amplitude. That's fine. But since it is color, and since the AI display is color, there's no way to put the two together in such a way as to show the AI information at the same time as we see the seismic amplitudes it was created from. It's always one or the other. Take your pick and take your chances. Fortunately, we aren't in the 70s anymore. Technology has moved on, and we don't need proxy amplitude displays anymore. Now we can display the real thing. These are seismic amplitudes. And whereas color, as you can see, makes them more amenable to the eye, we don't actually need it. And color can, in fact, be a needless distraction. We're better off without it. So now, maybe you can see where I'm going with this. We don't need color to show us amplitudes. We can get along just fine without it. And because we can, this leaves us with an entire new dimension that we can use to do some very interesting things. In this case, we will use our new dynamic displays, and specifically the multi-attribute version, to overlay the acoustic impedance value over our seismic amplitudes, thus restoring the seismic context back to our display. This is just one possible way to combine multiple versions or multiple attributes together using the new Seismic Terrain Explorer. There are a lot of others, including this one, which you can use to morph between different attributes. In this case, we're morphing between the seismic and the acoustic impedance. I'll zoom in a little closer so you can get a better view on what's going on. that will do for today, I think. This was just a very quick introduction to our dynamic displays and to why we believe that they will become almost indispensable tools in the future. To find out more about them and to download the Seismic Terrain Explorer, follow the link at the end of the video. For now, I am Dr. Stephen Lynch. Thank you for watching.